Hey Thinksters, what's up? It's Adam, and in today's video I'm going to be talking to you about NumPy matrix multiplication, and more specifically how to do correct, mathematical matrix multiplication in NumPy. Because if you've ever tried to multiply two NumPy arrays together, you may have got a result that you didn't expect, especially if you come from a maths background like myself. I studied maths at university and found NumPy's multiplication functions really confusing at the start. But fear not, in this short, sharp video, we'll be explaining everything you need to know about matrix multiplication in NumPy. So, let's get right into it. There are three different methods. All the syntax is pretty simple. You can get a bit more complex with them, but we're going to keep it simple for this article. Now let's very, very quickly go through them in the order of best to worst. So the best method, the one that we recommend, is using the at operator, and it has a nice little mnemonic. So like matrix, M-A-T, multiplication is at, basically, because the at is for matrices. Okay, you'll see it a bit more later. Now this only works in Python 3.5 and up because it was introduced into the language then. As you can see here, if we have matrix A, which is np.ones22, which is, let's first obviously import numpy as np, and if we set A is np.ones22. This means the shape is there's two rows and two columns, and we print out A here, we can see it's just all ones. So if we multiply that together, we're going to create B, which is the exact same. We do matrix multiplication, simply do A at B. We're going to do B is np.ones. Can you tell I've just woken up this morning as I'm filming this? There we go. Then we get the result we expect. And remember that matrix multiplication works by, if we're not sure, there's a link in the article to a quick way of explaining it. We'll leave that for another video. Next one you could do is np.matmul, stands for matrix multiplication. And you simply do, it's simply a function, np.matmul, a comma b, boom, then you get your output there. And the final one, np dot. Now, this is actually really to perform the dot product. So if you have a couple of vectors, you want to perform a dot product on them, you would use this function, which makes total sense. But if you put in some matrices, like 2D matrices, in there, it will actually do matrix multiplication. So we don't recommend using this one just because it's a bit confusing, especially for people that come from a maths background. Why, if I do the dot product, is it doing matrix multiplication? They're two very different things in maths, and they're usually not together. They're usually very different. So, why are there so many choices? Which should you choose? Before we dive into those questions, let's have a quick refresher on matrix multiplication and NumPy's default behavior and why it is that way. So, first off, what is matrix multiplication? If you don't know, check out this article by Maths is Fun. Really, really good article. Explains it, everything nice and quickly. And we go through it. You see, so we're timesing these two together. We do 1 times 7 plus 2 times 9 plus 3 times 11 to get 58. Explains it all very nicely for you. But the key reason that this is important for you watching this as a Python programmer is that matrices and arrays are literally the basis for almost every area of research. So machine learning, computer vision, neuroscience, any aspect of science, any aspect where you're working with numbers, you will 100% be using matrices, arrays, and matrix multiplication at some point. So this is something you definitely need to know. So because of that, how do we code it? So let's first figure out NumPy array's default behavior. And the default behavior for any mathematical function in NumPy, and anything you do to a NumPy array, is element-wise operations. And the reason this is the default behavior is just because it's so useful. And this was really kind of one of the reasons NumPy was created, because standard Python lists just weren't cutting it. So let's say we have standard Python list. So A is 1, 1, 1, 1, and we just want to add 5 to every element and create a new list B. We either have to write a for loop or a list comprehension. So if we have a for loop here, A is 1, 1, 1, 1, we have to initialize our empty list, then for x in A, B dot append x plus 5. And we have to do this calculation over and over again and loop through it. It's pretty complicated. First off, there's so many lines of code, and it's also really slow, as we will see in a second. Second one, list comprehension. They have a special place in my heart. I'm sure if they don't have one in yours right now, they will in future. Love list comprehensions. But A is, again, 1, 1, 1, 1, and we can just create it in one line of code this time. B is brackets x plus 5 for x in A. Lovely. Very nice, but still pretty slow. If we make our A a capital A to be a matrix and turn it into an array, then we just do np.array 1, 1, 1, 1, and B is A plus 5. Boom, there we go. All the elements of A have now had 5 added to them, and they're now all 6. This is really easy to read and is really, 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 really fast, as we'll see here. So I've done the exact same, but I've just made a list of length 1 million using list range just for demonstration purposes, because if you use one like this small, you can't always see the differences. And I'm going to use the %timeit magic command for IPython. So A is list range 1 million. Let's first do a for loop. So B is empty list. If we time it for x in A, b.append x plus 5, it takes 28.5 milliseconds, plus or minus like 5 milliseconds per loop. Reset B to empty list, and then let's do it again, but we'll do a list comprehension. So B is x plus 5 for x in A, 8.18 milliseconds. That's already like 3 times as fast as a list comprehension. But now, like, this genuinely blew my mind when I saw this, okay? I did not know. I knew they were fast, NumPy arrays, but I didn't know they were this fast. So we just have A is np.array A, remember our list, just list of range numbers from 0 to 1 minus a million. Then if we just create B is A plus 5, it's 81.2 microseconds. So I think there's 1,000 microseconds in a millisecond, I think. So this is 8,180 microseconds. So using arrays is 100 times faster than list comprehensions. Google doesn't realize that comprehensions is correct here. And it's 350 times faster than for loops. Insane. Crazy, crazy, crazy speed gains. You should always be using this. NumPy was created and optimized to be super fast when dealing with numbers. This is an incredibly, incredibly useful feature, and it works for all mathematical functions. So if we want to multiply every element in A by 5, we do the exact same. So C is A times 5. And if we can do the same for subtraction, for division. If we want to apply a function to a NumPy array, we can. It's incredibly useful. I'm sure you get the point right now. So all the mathematical operations act element-wise by default. So if you're multiplying two arrays together, NumPy assumes you want to do element-wise multiplication. So again, let's check out our np.ones. We got 2, 2. And then we've got our NumPy array. And here we're going to have, 1, 2, and then down here, we're going to have 3, 4. And if we do, still not fully awake yet. Let's close this list. Boom, there we go. If we're going to do matrix multiplication with these, we would expect, I guess we could just do it. But what's going to happen is all of these numbers are going to be times by these numbers element-wise. So we're going to have 1 times 1, 1 times 2, 1 times 3, and 1 times 4 to give us an answer of, well, the exact same here in this case, because we're multiplying everything by 1. But that isn't what would happen if we're doing matrix multiplication. We'd get a completely different answer. We'd actually get, let's see if we can figure it out. If we put the @ sign here, we get, boom, 4, 6, 4, 6. So that's kind of annoying, especially if you want to do matrix multiplication. And another thing is because everything is element-wise by default, the standard, like a core element, that one of the first things you learn about matrix multiplication is if we have a matrix with dimension m times n, that can be multiplied by any other matrix with dimension n times p. So we need these two to be the same, n times p. So we need the n, it's going to be an error obviously, but let's ignore that for the now. So these n's have to be the same, but m and p can be whatever you want. But obviously if you're doing this element-wise, then it's just not going to work. So for example, if we have np1s 3, 2 times np1s 2, 4, this gives us a value error because it's trying to do element-wise multiplication. So this first one, the number of elements is 3 times 2, which is 6, and the second one, it's 2 times 4, which is 8. So how does it can't do element-wise multiplication because there are a different number of elements there. So what do we do with the extra 2 here? Like what's supposed to happen? So you already know element-wise multiplication, super useful, and you will definitely use it, but you'll also want matrix multiplication. So you may have seen around on the internet the NumPy.matrix class, and maybe our answers lie here. Well, let's find out. So NumPy.matrix is a subclass of NumPy array, and it's pretty cool in that if you basically it works as you would expect a matrix to work in a mathematical sense. So if you create some NumPy matrix instances and then apply star, like i.e. multiplication, it's going to perform matrix multiplication. So let's check out this same thing. So this is our np1's example here, from here again, and we'll see that this, if we have arrays and we multiply them together, then we get, element-wise multiplication. But if we have np.matrix, and two of them, matrices, then we get matrix multiplication. Wonderful. Great. Problem solved. Well, not really. So this can cause and has caused so many issues. So especially in production level code, like if you have 20 matrices, and obviously you could have even more than this. This is a very small number. 20 matrices in your code and 20 arrays can get really confusing really quickly. You're going to have to either give them all like long names and be like, this is an array, this is a matrix. So you just have to type out loads. Your code is harder to read because you're always saying like, this is a matrix, this is an array, blah, blah, blah. And then if you accidentally like multiply two together, and you're expecting one result, but you get another, the star operator is like overloaded here because you're using the same operator, but you're doing completely different things. So code is really hard to read. It's really confusing, and it can be full of bugs. Actually, there was a quote today that I read from Free Code Camp. So I get their like weekly emails. I recommend you sign up as well. They're really cool, really interesting. Just as a side note, and the quote said, debugging your code is twice as hard as writing it. So if you write your code as cleverly as possible, by definition, you're unable to debug it, which I thought was really cool. It took me a while to understand that, but really nice quote. And if you're writing code that's like really complex and hard for you to understand as you're writing it, like when you debug it, it's gonna be crazy difficult. So that we feel is one reason why the NumPy docs as of version 1.17 say it is no longer recommended to use this class, even for linear algebra, which is what it was really designed for. Instead, you should be using regular arrays, and it looks like they're actually going to remove the NumPy.matrix class in future just because it caused so many problems. So you'll see it on old Stack Overflow answers, things like that, potentially even old articles, but do not use this anymore. It's out of date. It's a bad idea. So let's look at some other methods for matrix multiplication. So 2 involve function calls. Let's start with the one we don't recommend. We've already seen these, but we're going to go into more detail now. So NumPy dot. This, as the name suggests, computes the dot product of 2 vectors. Really simple syntax. Just takes 2 arguments, the arrays you want to perform the dot product on, or vectors you want to perform. Or vectors you want to perform the dot product on. Really. There's also a third argument which you can check out in the docs, but it's just to enhance performance. So let's say you have, if you actually want to do the dot product with a couple of vectors, we've got a few vectors here, and the dot product is you do the top times the bottom, so 1 times 3 plus 2 times 2 plus 3 times 1, which is 3 plus 4 plus 3, which is 10, and lo and behold, boom, we get 10. So this is odd in the dot product, if it has vectors as input, it will produce an integer or float. But if you give it matrices, as we see here, the output is a matrix or is an array. So again, this is a bit confusing too. This function is overloaded, and it can make your code confusing. But let's quickly go through this. So we've got some 2D vectors, so a 3x2 vector, a 3x2 matrix of 1s, a 2x4 matrix of 1s, and our output np dot 3x2, 2x4. And the reason I've chosen this is because of the shape. We expect a shape of 3x4 by standard kind of matrix maths here. And we check output.shape, and wonderful, it gives us the answer we expect. And then the output, everything is 2, and it's the right shape. Great. So as we've already said, this is confusing. np dot should be doing the dot product. It should be returning a scalar. It's not doing so. Even NumPy themselves do not recommend you use it, as we've already said. So we're going to move on now. That being said, though, if you want to calculate the dot product, definitely use it. Just don't use it for matrix multiplication. It is a great function. Next function, NumPy.matmul, the matrix multiplication function. Again, very similar syntax to np dot. So we're going to use the same example as before. So 3x2, 2x4, and the code is the exact same, but we just replace dot here with matmul. And again, the output shape is the same as above, and the output is the same as well. So pretty simple this really, I think. Function name is clear, pretty easy to read. Vast improvement over np dot just because it's clear and easy to read. And there's some advanced functions as well. But I'll refer you to the docs for that. I need to put a link in here actually. But for 90% of cases, this should be all you need unless you're doing some really advanced stuff. So could this be our answer? Is this the holy grail of matrix multiplication? No, it's not. We've saved the best till last. The Python @ operator. Goodness me, I'm excited. So the @ operator was introduced to Python's core syntax from 3.5 onwards, thanks to PEP 465. And there's a link to PEP in the article. So when I started out learning Python, I thought, gosh, these PEPs are going to be so confusing, so hard to read, all about these random little intricate bits of the language, and it won't make any sense to me. I'm a beginner. It's going to be so complicated. And that is true for some of the PEPs. But this one is incredible. I really, really, really recommend, if you're interested in this, to give this a read, because it's all written in very nice language, very easy to understand. And if you've understood my article, you will definitely understand this as well, because he gives so many reasons for why the @ operator is the best, why it was introduced, and yeah, it also talks you through like his thought process, like could we have chosen a different symbol? Why is this needed? All of that. I'm going to give you some summary here, but if you find this interesting, would really recommend giving the pep a read. Really interesting and easy to read. So the lovely mnemonic at is star for matrices. So very easy to remember. And the reason, kind of one of the main reasons they introduced this was because there wasn't a consensus in the community for how to properly write matrix multiplication. So we had star competing for two operations. So sometimes star meant matrix multiplication if you were using numpy.matrix. And then sometimes you'd use these function calls, but some people used np dot, some people used np.matmul. And as we'll see later on, they're actually like really hard to read. Especially if you're doing like more like matrix multiplication of like 3 or more matrices at once, which is really common in mathematical functions. Sometimes you might have a function that has like 3 different brackets, each containing like matrix stuff, and there might be 2 or 3 matrices in each one, and you times them all together. And it's really easy to read mathematically, but once you translated that using functions, it gets super complicated and really difficult to read, which is a problem because code is meant to be read by humans and then only by computers second. Computers obviously don't care about readability, but humans do. Also, they did some initial research, and it turned out that matrix multiplication was more common than floor division. So, but floor division already has its own syntax. So here we do like 10 divided by 4, we get 2.5. But if we do floor division, we get 2 because it rounds it down. It is a bit unusual that they added at to the core Python language when it's only supposed to be used with certain libraries. To me, that seems, as a learner of Python still, it seems like a bit confusing to the brain. Like, how do you add something to the language when it's for certain libraries? But they did it. They figured it out. Also, the only other time we use at is for decorator functions. So these are some like advanced things you can do. So for example, this isn't really helpful, but my decorator, and then you're going to define my function, and then and do some good stuff here. And basically, the decorator like enhances the function in some way. But we can get into that. That's kind of for another article. But the reason that's great is because you're unlikely to get confused, because decorators always start the start of a line, whereas if you're using at, it's always going to be like somewhere in the middle between 2 matrices, so you're never going to get confused. And really, like, it just works as you would expect matrix multiplication to. Well, almost. But let's dive into this. Our example from the start again. np.1s 22, np.1s 22, and we just use at. Wonderful. It's just a replacement for, if you thought this was multiplication, matrix multiplication. No, it's this, and it just works as expected. The only thing that's different is that from the real world in maths is that using at is left associative. So what does this mean? So in maths papers and things, you may see something like this, A, Z, X, where A and Z are matrices and X is a vector. You'll see this all the time if you're doing like eigenvectors, eigenvalues, equations like that. It's performed in maths in a right associative manner. So this means that like this is equivalent to the brackets around the Z and the X first. This is what happens first. So you perform ZX first, get the answer, and then you do a ZX. And again, this is because this is important because matrix multiplication is not commutative. So if something commutative, it means that where A and B are 2 matrices, it means that this is the case. So A times B is the same as B times A, but that is not true for matrix multiplication. Because let's say we have shape 2, 3 times 3, 4. This will work. But if we swap them around and we put 3, 4 first and then times 2, 3, we'll see that these middle ones don't match up. So it's not going to work. So But all of Python's mathematical operations are left associative by default. So if we do like a plus b plus c, it does a plus b first and then plus c. If we do a divided by b divided by c, it does it like this. And it's the same for any combination of mathematical functions. So let's do a numerical example where we explicitly make this right associative. So 2 times, and then in brackets, 3 minus 4. So 2 times minus 1 is minus 2. And then we're going to have this left associative. So 2 times 3 is 6, minus 4 is 2. And then if we do it without brackets, it will show us how Python calculates it. Is it going to be left associative and give us 2? Or is it going to be right associative and give us minus 2? And we'll see that the output is 2. So you can read more about this in the PEP, and I recommend you do. But there wasn't a consensus in the community as to which was better. And since everything else in Python is left associative, they thought, let's just make at left associative too, because then, everything's the same and there's nice consistency. So, should you just use at whenever you want to do NumPy matrix multiplication? Let's get into it. So there is debate as to which method is best, but as I've already said a few times actually, you should always use the at operator. It was introduced to the language to solve this exact problem, and if you read the PEP, I think you'll just be entirely convinced about why it's great. Our personal favorite reason is that it's just so much easier to read if you multiply 2 or more matrices together. So let's increase this font size, boom, and let's say we want to calculate A, B, C, D. So matrix A times matrix B times matrix C times matrix D. If we use the function calls, it's so difficult to read. np.matmul, 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 A, B, C, D. Like where are all these brackets coming from? What's in where? Really confusing and difficult. Or just A at B at C at D. Wonderful. Okay. I think this is it just shows you the power of the at operator right now. The mathematical symbols directly translate to the code. There's way less to type, and it's much easier to read. Why wouldn't we be? This is obviously the choice. Though unfortunately, if you are using an older version of Python, you will have to stick with np.matmul. But since 2.7 development is being stopped, and Python's moving on. Hopefully that won't be an issue to many of you, especially if you're a learner. You should be learning and using the latest version of Python you can. So there we have it. You can now multiply 2 matrices together. You know why it's so important, and you know that you should use at for matrix multiplication. If you are interested, really recommend reading the PEP, and if you want to go even further into NumPy, there's other functions that deal with matrix, array, and tensor multiplication. So tensor as in TensorFlow. So if you're doing machine learning, you will need to learn the difference between all of those. Some functions to check out are np.v. For the complex conjugating dot product, tensor dot to sum products over arbitrary axes, and einsum for the Einstein summation convention. Check out these references as well if you'd like to dive into kind of the research I did for this article. Really appreciate you watching. Thank you so much. If you haven't, click the subscribe button and the notification bell under this video. We're posting new content all the time. We want to take you from zero to hero in Python. And if you want to learn more about this and think, Adam, this is really interesting, I would love to be able to do Python all the time and make this my full-time job, well, you can. It's literally what I did. I've been teaching myself the last few months, and I took the Python freelancer course. There should be a link in this video, under this video, or on the article page to it, and it's literally changed my life. I'm now traveling the world, working as a professional Python freelancer, all because of this course. Teaches you everything you need to know, even teaches you Python if you don't know that yet, and gives you all the ins and outs and how to start working on Upwork, how to successfully get land clients and negotiate, build your own website to really scale it up to like 10K a month. So really, really great program. I am like the product of it myself. It is the reason I'm talking to you today. If you have any questions, post in the comments. If not, really appreciate you watching. Thank you so much. Hope you have an awesome day and see you soon.